Students, we are expected to obtain the orthogonal trajectories for the family of cardioid given in polar coordinates. So r is equal to a times of 1 negative cos theta. So this is a new way, or I should say another technique for us to obtain orthogonal trajectories in polar form. So having mentioned that, let me just show you with this illustration. So step number 1, in r is equal to a times of 1 negative cos theta. So I'm going to find differentiating with respect to theta. So this is going to give me dr over d theta is equal to, a is a constant, differential of 1 is 0, differential of cos theta is going to be negative sin theta. There is already a negative sign, so this is going to give me a positive sin theta. So I got a times sin theta. Now a is an arbitrary constant. Now we'll have to get rid of this. So if I were to take this as 1, I'm going to take this as 2. From 1, I can rewrite this as r over 1 negative cos theta is equal to a. So I got an a there. So therefore, using this, I'm going to rewrite 2. So how do I rewrite 2? So therefore, I got dr over d theta is equal to, in place of a, it's going to be r over 1 negative cos theta times sin theta. So this is what I've got. Now I would want to represent this. In fact, I would have to change everything. So how I'm going to change it? I'm going to use trigonometric formulae. So I know that sin 2 theta is equal to 2 times sin theta cos theta. That's fine. Now if I were to take 2 theta is equal to some t, then this is going to be sin of t is equal to 2 times, in place of theta, I will have to substitute t over 2. So this is a substitution that will come into place. So this is going to be sin of t over 2 times cos of t over 2. So this is what happens actually if I have sin t. But in this case it is theta. So I'm going to rewrite this as 2r times. So that's fine. Now there is another formula. What is the formula? 1 negative cos 2 theta divided by 2 is equal to sin squared theta. So this is the formula. Now if 2 theta is equal to t, so therefore I can rewrite this as cos of t divided by 2 is equal to, so this would mean theta is equal to t over 2, right? So this is going to be sin squared of t over 2. This is provided, of course, I have things in t. So in fact, I can go one more step further and rewrite this as cos of t is equal to 2 times sin squared t over 2. So this I can very well do it. So if you have 1 negative cos t, you can replace it like this. But in this case, it is 1 negative cos theta. So I'm going to replace it as 2 times sin squared of theta over 2. So that's fair enough. So now I can cancel the 2 and 2. And I can cancel a sin theta over 2 and a sin theta over 2. So this is going to give me r times cos of theta over 2 divided by sin of theta over 2, which is nothing but r times cot theta over 2. On the left I got dr over d theta. So that is a good simplification. Now just as we had step 2 in Cartesian forms, there is also going to be a step 2 here. But in this case, what is that step 2? I'm going to replace dr over d theta as negative r squared divided by dr over d theta. This is the replacement I am going to do. Have that in mind, and don't forget this. So negative r squared divided by dr over d theta. So if I were to take this as 3, so therefore I can rewrite 3 as, in place of dr over d theta, it's going to be negative r squared divided by dr over d theta is equal to r times cot theta over 2. Now I can cancel a r and a r, and I can flip this. If I were to flip this, this is going to be d theta over dr with a r is equal to cot of theta over 2. Now I can push this down and perform variable separable. So this is going to be d theta over cot of theta over 2 and dr over r. Now cot theta is nothing but cos theta over sin theta. So if I were to flip this, this is going to give me sin theta over 2 divided by cos theta over 2 and times d theta is equal to dr over dt, dr over r. So what is this? This is nothing but my integral tan theta over 2 times d theta. Now what I wish to do, I would like to first get rid of this theta over 2. So I'm going to say theta over 2 be equal to sum t. So that means d theta is equal to 2 times dt. So if I were to make that substitution, this is for your understanding. So this is going to be integral tan of t. In place of d theta is going to be 2 times dt. So I got integral tan t. Now how am I going to integrate this? This is going to be 2 times of sine t divided by cos t. Of course I have got a formula, but I can substitute that formula. But before I go substitute, I would like to show you all how and what is exactly happening. So this is going to be cos t is equal to sum u. So negative sine t dt is equal to du. So this is going to be equal to, in place of this entire component, I'm going to say du divided by u, which is going to be ln of u. Of course there's a 2 then with a negative sign. Now my u, what is my u? My u is nothing but cos t. So it's going to be negative 2 times ln of, I substitute cos t, so this negative goes to the other end, and that would become 2 times ln of 1 over cos t, right? Now this 1 over cos t is nothing but secant t, so I can very well write this as secant t. In fact, I can write this as secant square t, because I can push this 2 there. Now my t is theta over 2, so I have to bring it back here. So let me just do that. So this is equal to ln of secant squared of theta over 2. So this is what I got for integrating tan theta over 2. Okay, so this is going to be integral sine, that's fine. This is, let me rewrite that. This is nothing but integrating tan theta over 2 d theta. This is integrating dr over r. The integration of this is going to be negative of ln of secant squared theta over 2 is equal to integral of this dr over r is going to be ln r. I can just place a constant as ln c. Now I can actually push this negative sign to the secant squared and write that as 1 over secant squared theta over 2, which is equal to ln r plus ln c. But secant theta over 2 is nothing but 1 over cos theta over 2. So therefore secant squared theta over 2 is nothing but 1 over cos squared theta over 2. So if I were to use this, this is 1 over cos squared theta over 2. I can flip it. So I get ln of cos squared theta over 2 is equal to ln a and ln b. This is going to be r times, in fact let me write that on as ln of r times c. I can get rid of ln both sides, so that would mean I get cos squared theta over 2. Of course I get r times c, but I can push the c down over here. So if I were to push the c down, I would get 1 over c times cos squared theta over 2 is equal to r. This is what I get. Now c is an arbitrary constant. Now moving back, I would like to draw your attention to this all important formula. So what is that all important formula? Now let me just use this space. So what we have got now r is equal to 1 over c times cos squared theta over 2. Right, this is what we have got. I want to show you this formula. 1 positive cos 2 theta over 2 is cos squared theta. Now if I take 2 theta is equal to some t, then I can rewrite this as 1 positive cos t divided by 2 is equal to 2 theta is equal to t, therefore cos squared t over 2. Right, so there is a formula that is of this fashion. Now I've got cos squared theta over 2, so therefore what I can do is I can rewrite cos squared theta over 2 as 1 positive cos theta divided by 2. How is it possible? It's because of this formula that we know, right? Of course, I have placed in here as 2 theta. Probably if you are a little bit confused, I can just use it as cos 2a. This is cos a and 2a. So 2a is equal to t. So therefore, in place of a, I can substitute t over 2. So that's exactly what happens. So this is for a. So if I were to translate this to theta, this would become cos square theta over 2 is equal to 1 positive cos theta divided by 2. So that is what we are going to do. So if I were to take this as sum 5, okay, therefore I can rewrite 5 as r is equal to 1 over c times 1 positive cos theta divided by 2. So this is what I have got. Now this can be rewritten as 1 positive cos theta divided by 2c, which is r. Now let me write that down here, the final one. So what we have got here, r is equal to 1 positive cos theta divided by some 2 times c. So I want to replace this as 1 over 2c times 1 positive cos theta, which 1 over 2c can be replaced as some arbitrary constant, capital C. So this is going to be c times of 1 positive cos theta is equal to r. So this is the final solution that we are looking for. So this is going to be those families that are actually the orthogonal trajectories for the family of Cardiac. So this is the final solution, and we can box this. I hope this is quite a sum, and I hope you understood this. Thank you, students. Students, we are given this question: find the orthogonal trajectories of the family of curves r raised to the power of n is equal to a raised to the power of n times cos n theta. A is the arbitrary constant there. So step number 1, I will start off like this. This is step 1. This is given. So given is r raised to the power of n is equal to a raised to the power of n times cos n theta. So what I'm going to want to do is I would like to take ln on both sides. So if you had to take ln on both sides, it's going to be ln r raised to the power of n is equal to ln a raised to the power of n times cos n theta. Now there is a formula, ln ab is equal to ln a plus ln b. Using this formula, this can be rewritten as ln a raised to the power of n positive ln cos n theta, and there is also another formula which states that ln a power n is equal to n times ln a. So this is going to be n times ln r. So fair enough. In fact, I can also rewrite this, but there is no point in writing this because this is a constant. It's going to perish. So now I'm going to be differentiating with reference to theta. So differentiating with reference to theta both sides. So what happens if we are going to do this? So this is going to be differential of ln r is going to be 1 over r times dr over d theta. Differential of this is 0. Differential of ln cos n theta is going to be 1 over cos of n theta times differential of cos is negative sine n theta, n here. So now I am going to rewrite this as n over r dr over d theta is equal to negative n times tan n theta. Of course n and n can be cancelled. So now I have 1 over r dr over d theta is equal to negative tan n theta. So this is what I have got. So now what we got to do is we will have to perform step 2. What is step 2? dr over d theta is equal to negative r square divided by dr over d theta. So we have to perform this replacement. So if I were to take this as 2, therefore I can rewrite 2 as, in place of dr over d theta, I'm going to get negative r square divided by dr over d theta is equal to negative tan n theta. Of course, this is going to become positive. R and R can be cancelled. This is going to be R times d theta over dr is equal to tan n theta. Now I'm going to separate this by variable separable, so I would get d theta divided by tan n theta is equal to dr over r. Now this can be rewritten as, I need to integrate this, so sine theta or cos theta. When I flip it, it will be cos n theta divided by sine n theta times d theta is equal to dr over r. So we need to integrate this. So we will perform the integration in the following fashion. Now let me show you how to integrate this particular quantity. So I'm going to use this space here. So I got integral cos n theta divided by sine n theta times d theta. I'm going to retain or rewrite this as cot n theta d theta. Now let me take n theta to be equal to some u. So this one would be n times d theta is equal to du, and then my d theta is du over n. So I can rewrite this as 1 over n for d theta, and then I will have du there. So in place of d theta, I am writing du over n. So the n is placed over here. So followed by cot of n times theta is u. So this is what we have to integrate. I know the formula, but just for the sake of understanding, I am going to be making a substitution. So this is 1 over n integral cot u is going to be cos u divided by sin u times du. I am going to take, let sin u be equal to some p, so cos u du is dp. So this is going to be 1 over n, cos u du is dp, sin u is p, so this is going to be 1 over n ln p, which is 1 over n. My p is nothing but sin u, but my u is nothing but n theta, right? So I need to revert it back. So this is going to be 1 over n ln of sin n theta. Of course, there's an arbitrary constancy. So all of this I did just to give you an air of understanding. So I can directly substitute this particular output here. So this is going to be 1 over n ln of sin n theta. This is going to give me ln r. Of course, there is an arbitrary constant which I will have to place in. I will write the arbitrary constant as some ln c. Now I want to get rid of this n, so I will have to multiply every quantity by n. So that would give me ln of sin n theta is equal to n times ln r positive n times ln c. Now there is a formula, a times ln b is ln b raised to the power of a. I can write that. So this is going to be ln sin n theta is equal to ln r raised to the power of n positive ln c raised to the power of n. Now this is an arbitrary constant, so I can actually place this as some entire c, but before that I will have to make some simplification. This is going to be ln c raised to the power of n, and this is going to be ln r power n minus ln sin n theta. This is what I get. Now there is a formula, ln of a negative ln of b is ln of a over b. So by this is going to be ln of r raised to the power of n divided by sin n theta. So this is what I got. Now this is ln, let me write that down, ln c raised to the power of n. Now I can remove ln both sides. So if I were to remove ln both sides, this would give me c raised to the power of n. This is some constant, and r raised to the power of n divided by sin n theta. Now what you can do, you can replace this by some k is equal to r raised to the power of n divided by sin n theta. Now I can rewrite this as r power n is equal to some k times sin n theta. So this is a beautiful curve, family of curves, and that is a good place for us to draw the red line. So this is a beautiful question, students. I hope you understood this. Thank you.